Advanced Conduction lecture series, and today we are in our lecture 16. So I have covered almost all the topics of B.Tech level heat transfer. One topic is left, and that is the lumped mass analysis, right? If you have a solid ball surrounded by a fluid, so then can you consider that ball as a lumped system, and what do you mean by lumped system and all? So don't worry, I will cover that also. Now those of you who are thinking that I am here only to study the advanced things, so let me tell you, there is nothing called advanced, there is nothing called very simple. You have to have the concept. Okay, if you say that I know separation of variable, I know Bessel function, I will talk about Bessel function today, by the way. So I know all these things, but now if I am given a simple problem of a lumped mass analysis that I cannot solve, just because that is a B.Tech level heat transfer and I am just out of touch of B.Tech level things. So that is not something that a professor will expect from you. So if you are in your M.Tech, then don't expect that you will not be asked from your B.Tech concepts, because those are the basics. You cannot build a good building if you don't have a good basic, right? So uh, that is why, please don't be overconfident about all the things, and try to study everything from the basic. If you don't know about the conduction equation and you say that just give me the equation and I will solve that by the separation of variables, so that will not work, right? You have to develop the conduction equation for that, and you have to modify and simplify the conduction equation. Okay, so enough talking. Today I will teach about something that scares almost everyone who studies the advanced conduction, and that is the Bessel function. But don't worry, I will give you the poison very slowly so that it doesn't hurt you. Okay, so today is the lecture 17, sorry, 16, right? Today is lecture 16. So we will solve a problem today, that is, you can think that as the extension of the problem that we have solved in the previous lecture. So what did we solve in the previous lecture? A problem for a fin having a constant cross section area along the length. So today we will solve the same problem but for a fin having a varying cross section area, and more specifically a linearly varying cross section area. Okay, so first just quickly let me draw the fin. Okay, so the fin is a triangular fin here. Okay, so this is the fin. Okay, this is the fin. I think it is clearly understandable that how the structure is, right? And this is the fixed wall. So this is the base, and now I need to draw the coordinate axis, right? So here let me take any other color, maybe this one. Okay, okay, so this is not very appropriate. Okay, okay, so consider this as our x-axis. Okay, this should pass through this point also, but okay, and this is our y-axis. Let me, okay, so I could have choose the green color, right? That would be more effective here. Okay, okay, this is X and this is Y and this is Z. Okay, this is the origin. Clear. Now I need to give you the dimensions. So this is the same 2h. Okay, that is each part is okay. So again let me take capital H because small h is our heat transfer coefficient already, and this is our width. This part is the width, let me term is W. Okay, and also we have our length from this to this. This is L. Clear. So this is our fin. Okay, so this time uh, I am not explaining that why I will consider only the x direction heat transfer. Okay, so but you must have the reason in your mind that why are we doing that. Okay, so your homework is here. Write the reason or write the condition depending on which you can formulate the problem as a one dimensional okay, you can formulate the okay, you can express the temperature field T as only a function of x. Okay, so here T is not a function of y or z. In other words, I can also write T is constant on any yz plane, right? Okay, so now what is the basic step? Now I will suggest you that don't mug up this equation, that is the governing equation here. Okay, this governing equation what I have derived, this is, that is where it was. Okay, I will suggest you that don't mug up this large governing equation, that is this one I am talking about, this one. Okay, don't try to mug up, because honestly if I talk about myself I will not able to mug this up, and that is why I will also not advise you to remember this or memorize this. Rather go from the basics, choose a elemental control volume and perform your analysis. Okay, so for that let me copy this diagram of this triangular fin. If I will, now I need this. Okay, it is nicely copied. Okay, so now again you have to do one thing, that is you just take a elemental control volume, চাপ নেই প্লাস তো ঠিক আছে, অসুবিধা নেই কোনো? না, এডিট করার জন্য নয়, আমি এটাতে জাস্ট আর কি মানে আমারই বন্ধুদের পড়াচ্ছি, তো এটা খুব চাপের কিছু নেই, মানে জুনিয়রদের পড়াচ্ছি অবভিয়াসলি, বাট স্টিল যায় আসে না কোনো, ঠিক আছে? ওকে, so sorry for that, my roommate has come, so I have to also take care of the fact that no one is getting irritated or being uncomfortable for me because of me. Okay, so back to the study. Array, what has happened? Okay, so this is our elemental control volume. Okay, and if you see the 3D view, so let me draw it very clearly. Not with crooked lines. Okay, so this again not with green, because green is already our coordinate axis. So let me use this time this blue color maybe. Okay, so this one and this one, and if you draw the 3D view, then you will get something like this. Okay, so this one, we will get something like this. Clear? So this is our elemental control volume, and this is at a distance x. Okay, so this distance is x and this width is dx. Okay, again I warn you that this thing is not dx. Okay, this is something maybe ds, or at first we should write this as del, not d, then we will take the limit, right? Okay, so the thickness is delta x. Clear? So now again you have to just apply the simple energy balance here. So for that, just see that what are the energy interactions. Firstly, we have heat that is going inside is q dot x, and heat that is coming from the control volume, that is q dot x plus delta x, and also we have heat convected outside from the, that is q dot convection, right? Only these three things we are having. Okay, so if we write the thing, that is simply q dot x minus q dot x plus delta x minus q dot convection equal to 0. And why it is equal to 0? Because it is at steady state. These subtle things are very important, right? If I am the examiner, I will surely deduct some marks for these things. Okay, again feel lucky about that fact that I am not your examiner. So now again we have to manipulate this to get the temperature as our variable, right? So what is q dot convection? Obviously take h as the heat transfer coefficient for the slab and environment, and T ambient as the temperature of the environment. So this will be this into area of x into T at a position x minus T ambient, right? This is equal to 0. Then what we are having, then this one, and let me write the area now. So this will be perimeter x into what? Into delta x or delta s. So be very careful, I am again warning you, that is this will be delta s, not delta x. Okay, so for some specific cases delta x can be approximated as delta x, but from the fundamental point of view, never write delta x, right? So now this, still I will write p of x, and delta s is what? Now I will directly write delta y by delta x whole square plus 1. Okay, and this will be here t minus ta. So this t is t of x as a function of x. Okay, I am not writing that here. So now I can take a minus common here, and I can divide by delta x, right? So h minus p of x, so 1 plus delta y by delta x whole square, right, into t minus ta is equal to 0. Now you take the limit. See, I am doing the whole exercise again so that you become acquainted with the whole thing. Okay. In the examination also, you are supposed to write all the things like this very clearly and all the assumptions, but obviously as briefly as you can, because you have to also take care about the time in examination, right? Okay, so as you take the limit, this thing will become minus d dx of q dot of x. Okay, and this thing will become this into t minus ta into 1 plus slope, right, dy dx whole square equal to 0. Now from Fourier's law I can write this as this into k into a, that is a function of x. So either you can write the suffix to denote that it is area at x, or you can write the at bracket x. Okay, so this is dt dx. And why it is dt dx and not del t del x? Because I have already suggested before solving the problem, that is t is not a function of y and z. And now perimeter of x, I am still writing it as just p of x, but afterwards I have to write the actual function, okay, to solve the problem. Till now I am just writing the general governing equation. Clear? So now if I take k as my constant, then this will become dA dx into dt dx, right, plus k into a of x, that is a function, and this one minus h into p of x into root over of 1 plus slope whole square, clear, into t minus ta. I hope that is clear to you, right? So now let us come to the specific problem. So we have to find some functions, right? Here we don't know this ax, we don't know this px, and also we don't know this dy dx. Okay, so let us see that we have the fin as triangular fin. Okay, so it is clearly a equation of straight line. If I have to write the equation for height, okay, so let y be the height of the fin at a distance x, clear. So if y is the height at a distance x, so then I can write that let my equation for y is equal to mx plus c, clear. So I know that at x equal to 0, my y is equal to what? H, capital H, and at x equal to L, my y is 0. So from this you can see that this will be what? This will be your H by L into x. Is it happening? No, we are wrong. So let us put the things. So H is equal to C here, and 0 is equal to ml plus C. So m is equal to minus C by L, that is minus H by L. So the equation of line becomes y is equals to minus H by L into x plus H. That means this is y is equal to okay, this is okay, this much is fine, I guess. So the moment I know the equation for y, then I can find the slope, right? So dy dx therefore becomes minus H by L. Clear? So now I know the dy dx, that is minus H by L. Now what is Px? Let us find the Px now. So if you see the diagram, then Px is just this perimeter, okay, this one. Now this time you have to apply your power of visualization, that what is this cross section. So this cross section is nothing but a rectangle having this side as how much, 2 into y, and this as a constant w, right? So the perimeter x will be your 2 into 2y plus w. Clear? I hope that is clear. So now this is equal to 2 into 2y plus w, and that is equal to 2 into again 2h minus 2h by L into x, clear, plus w. Okay, so this is my P of x, and what is my A of x? Again, just be very clear that A of x is what? The area which is perpendicular to the direction of the heat transfer. So that is this area. Clear? That is this area. Okay. So that area will be what? This, that is 2y into w. So area of x, that will be 2y into w. Clear? See, we have found all the functions. So this is 2yw, and that will be 2h minus 2hx by L into w. Okay. So now I think by this time I expect you to be clear about the reason that why I am able to consider the fact that t is not a function of y and z. I mean, what is the condition? I would like you to put that in the comment. Okay, that is what is the condition. So if that condition is valid, okay, so can I write, so let me write here the dy dx also. Okay, that is your minus h by l. Okay, so the condition is, that is my h comma w is much less than L. So if that is so, can I write that my dy dx whole square is much less than 1, and in that case can I write that this thing is almost equal to 1, and if I can write this, so then now I can modify my governing equation by saying that this is almost equal to 1. Okay, so this was one approximation. Okay, so let us write the governing equation applying this approximation. Okay. So just let me copy this governing equation. So I have copied this. Now I will directly say that this is equal to 1. Not equal to 1, it is approximately equal to 1. And now let me put this value of px. Now what is the value of px? That is this 2 into 2h minus 2h by L. So 2 into 2h minus 2h by L into x, right, plus w. And what is the value of ax? Ax is 2 into or 2h minus 2h by x is 2y into w. Okay. Okay, so another thing I need to know, and that you can get it from here, that is what is my dA dx. So dA dx is, you just differentiate this one, that will be my 2h w by L. Okay, so this is minus 2h w by L. Clear? Okay, I hope I have not done any calculation mistake, but still if you find anything that is be it a calculation mistake or be it something illogical that you think that is this step is not logical to me, please write that in the comment box so that I can I can correct it in my next video. Okay, so now if I write the equation, so this will be minus, okay, minus 2hw k by L dt dx. Okay, so again plus, now this time I will be having 2h minus 2hx by L into w into second derivative of temperature, and then again I will have minus h into the very ugly and big term is here, right, and again T minus TA is equal to 0. Okay, so now this is something that is very much scary, right? Okay, so let us see if we can simplify it more or not by applying any other assumption. Okay, so here what I can do, let me see. Okay, see, okay, so I think I cannot do any assumption after this. Okay, I cannot apply any assumption after this thing. So now I am stuck, right, because I have got the governing equation. So this is your governing equation, and you know also the boundary condition. So first of all, how many boundary conditions do you need? You have a second derivative for temperature, and temperature is the only variable here. So if you are having a second derivative of temperature, that means you need two boundary conditions, right? So let me write the boundary conditions here. So the first boundary condition is at x equal to 0, my T is equal to TB, any base temperature, and my second boundary condition that you can choose. So I will choose that my x tends to L, my T is tending towards TA. So now this is which case that I am considering? This is the long fin case. Okay, long fin case. Okay, so now I have to solve this. So now the main part of the Poisson will come. Okay, that is the Bessel function. Now I have to go back to my notes because no one actually, you should not do the dare of memorizing the Bessel function. Okay, so I have here, uh, I have written here the basic form of the Bessel function. Okay, so let me write it. Okay, so before that, what I can do, I guess, uh, you can also non-dimensionalize the equation if you want, or let me see if I can do anything. No, I think I cannot do anything here. So now let me introduce the Bessel function. So a brief about Bessel function. Okay, don't worry, in the actual examination also you will be given the tables of tables and graphs of the Bessel function, and you don't need to memorize anything, not even the Bessel equation that I will be writing just now. Okay, so the Bessel equation general form is, we have here eta square eta 2 and eta square d 2 theta d eta 2 plus 1 minus 2a, okay, eta minus 2b eta square, something has fallen down. Okay, so that will be uh, d theta d eta plus c square d square eta to the power 2c plus b square eta square minus b to 1 minus 2a eta plus a square minus c square, and this is n square, not eta, this is n square into theta is equal to 0. Okay, so here where my a b c d are constants. Okay, you will get this from any standard book actually, but still. Okay, now you have solution of Bessel function like this. Okay, where it is written the solutions of the Bessel function. Okay, so now if I talk about the solution of Bessel equation, okay, so this equation is nothing but the Bessel's equation. Okay, so that will be the solution. It has 4 cases. If now my n is positive, not positive, it is non-negative, and it is, or I am writing the same thing in another notation, that is the, so this is nothing but the this is nothing but the positive integer notation. Okay, and that will be, if this is the case, then my solution will be y of x is equal to x to the power a exponential, or I can write directly here e to the power bx c1 jn c plus c2 yn dx to the power c. Okay, so now I think that you are thinking that what are these values. So this is the Bessel function of nth order of first kind. Okay, so let me write this. Okay, let me write this separately. Okay, so this is, how much time has elapsed? I have not seen. Okay, 35 minutes. Okay, so Jn is Bessel function of first kind of the order n, clear, and capital Yn is Bessel function of second kind of the order n, clearly. Okay, so now 2, if n is not equal to 0, okay, if n is not equal to 0 and neither it is positive, neither it belongs to positive, okay, and if my d is real, and I'm sorry then, okay, so here also I was having this condition, that is my d is real, so this is my second condition, then my y will be x to the power a e to the power bx, again c1 jn dx to the power c plus c2 jn dx to the power c. Okay, similarly I have two more conditions. Okay, I think I should not waste the time here, okay, by writing these conditions, because you don't have to memorize this, just learn that what is Bessel function, I mean just learn this notation, that is this Jn is the Bessel function of the first kind of order n, and Yn is the Bessel function of the second kind of order n. See, honestly, as an engineer you don't need to I mean think about these things, right, because your 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 task is to formulate the problem, is to model the problem, okay, after that the equation can be solved by any mathematical software or any good mathematician, okay. Now you don't have to delve very deep into the uh, into this Bessel function, that how the Bessel function actually originated and all the things. You can, obviously, that is a very good thing. I would encourage you, if you want, then you can study the deep level mathematics, but that is not required, okay. Everything will be given in the examination paper, everything about Bessel function that you will need, but before going in the actual examination, just solve by yourself at least one problem, okay, by yourself, because now now you will see that why you need to solve. So now we have to compare, so let me write these two equations side by side, okay. So copy and paste, okay, this is one equation, so this is my governing equation, right, and this is my Bessel equation B, okay. So now we have to actually compare, okay. So compare which thing? We have to compare the coefficients, okay. So are we having anything similar here? So what you can do is, okay, now this problem has become mathematically a bit more challenging. Why? Let me show you. Let me again copy this thing. Okay, see this form here, this form here and this form is not looking very similar, right? I mean these are not comparable, because I need to have here, if I am having here x square, I need to having here x square also. That is, if I am having here the second derivative, I need to have my second derivative here also, right? But I am having something else here, totally different from x square. Okay, so how can I convert this into this form? So let us see that. So first of all, uh, what I can do is, let me write from the second term. I will take this 2h common here, so 2h wk into 1 minus x by L, okay, d2x dx2, clear, plus now I will write the second term, sorry, the first term, 2h wk by L, clear, then dt dx, then the third term, so I have here 2 small h, and if I take again the 2h common here from the term, then I will have 1 minus x by L plus w by 2h, okay. I am not having here any k or any L, clear, okay. So now divide the whole equation by this one, that is 2hwk, then what I will have, I will have 1 minus x by L d2t dx2 minus 1 by L dt dx minus now 4h, right, I have divided by, okay, 4h I have divided by 2hwk and w by 2h into t minus ta is equal to 0, clear. I am just doing these steps to make this equation comparable with the Bessel function, I mean Bessel equation, sorry, okay. So now let me do a transformation. See, if I am having x here, I also need to have x here, x square here, but only x here, but I am having 1 minus x by L here. So I will now do a transformation, eta is equal to 1 minus x by L. If I do that, then what will be my dt dx? That will be, I have done this for several times before, okay, this will be my, now I can write this into this, right, so this will be this into, now this will be minus of 1 by L, clear, and similarly what will be my d2t dx2, so that will be dd eta of dt dx into d eta dx, and that will be what, sorry, I have done here a mistake, this will be this, so that will be minus 1 by L common d2 t d eta 2 into again 1 minus 1 by L, clear, and that becomes your 1 by L square, right. And I have also taught you this thing before, so because this 1 is a constant, then it will not matter after the, after doing the uh, derivative, right. So but as I am having L here, so here it will be a L square. I have shown, sorry, I have shown, sorry, yeah, I have shown this thing before, that how to do this faster, okay. I mean how can you skip all these untidy steps, right? So now let me again copy this and paste it here. Okay, so then my equation becomes, so this is nothing but my eta, right? And this will be eta by L square d2t by d eta 2 minus 1 by L. Now this will be dt d eta into minus 1 by L, right? Why? Because this is minus x by L, so you can consider it as x by minus L. So whatever you are having in your denominator, you have to put that in the multiplied fashion with that variable, right? These things will save your time actually, these small concepts. Okay, so now here I can make some simplifications, that is this will be cancelled out, so 2 and 2 and capital H capital H, so this will be 2h by wk, right? So again this is 1 minus x by L w by 2h into t minus ta is equal to 0. Okay, this is a single term as well as this. Okay, okay, so now the equation has become a bit more, I mean more sober, right? Still, see, I can do one more simplification. So now I take one assumption, okay, that is my w, that is the width, is much less than my height. So this is not a very necessary assumption. Okay, so let me not take it right now, but up till now I can write this as my eta. Clear? Okay, so my equation becomes, and one more thing, you need here eta square, right? Not only eta. So let us multiply the whole equation by eta. So eta square and also by L square. Okay, I am multiplying the whole equation by eta L square. So that becomes eta, this one minus, and this will be plus, minus, so 2h by wk into eta into L square, right, into eta plus w by 2h, clear, into t minus ta, everything in a single term, that is equal to 0. Now this is this plus eta into dt d eta minus 2h eta square L square by w into k plus, minus, or okay, now everything has become a bit more complex again. Okay, okay, so up till now let me see that if I can compare this with the Bessel equation or not. Okay, let me again copy the Bessel equation, copy, okay. So now can you compare it? See here, this term is same, totally same, and from this and this, what you can say? See this carefully. So I can say that this eta is equal to this term. That means my b has to be 0 and my 1 minus 2a has to be equal to 1, sorry, yes, my 1 minus 2a is equal to 1, that means my a is equal to 0, right? That means by comparing these two, this, okay, I should use any other color, maybe this one only, this and this, I can say that my a equal to b equal to 0, right? I have got my a and b. Now I need to know my c and d and small n. Okay, so now see here, I have theta here, right? And I also have t here. Okay, so then what else I can do? But I have one more minus ta here. That means if I multiply this whole thing in this t and minus ta, then I will have one extra term, So if I multiply this term with t, that will become equivalent to this term. That is some term into t, that is equivalent to some term into theta, because here this t is equivalent to theta. But now here will be an extra term, this into multiplied by minus ta. But here I am not having any terms such like, I mean like that. So to deal with this situation, let us define another variable, that is t minus ta equal to theta. Okay, see, I could have done all this thing before, that is let me define a variable eta, theta, but why I am defining this? To make the equation comparable with the Bessel function, Bessel equation, right? So if I now uh, define this one, so here in this equation nothing much will change, so everything will become, so let me copy this equation, because there will be just one change. Okay, I will not write the whole equation again. Okay, so here there will be only one change, that is this term will become theta. Okay, because if you take the derivative here, your dt d eta is equal to d theta d eta, because ta is a constant. Okay, and everything is same other than that. So now you can again compare this whole term. Okay, I am just copying this part. Okay, so now you need to compare this whole part with this thing, including this minus, right? So let me compare this. Okay, so let me first expand this. So this will be what? 2h eta square L square by W into K plus 2h L square by K into 2h. Okay, because W and W will be cancelled out, there will be one eta, right? This whole term into theta, and one minus is there, and let me take this minus inside. Okay, I think I have done it correctly. These 2's I can cancel it out. Okay, now let us compare. So if I compare this term here, okay, so let me first see that I am not, okay, so firstly this is equal to 0, this is equal to 0, clear? Then what else I am having? This is equal to 0, and okay, the c and n both are constants, but I am not having any constant. Okay, that means I am having my c into n equal to 0. remember, you cannot say that your C is 0 or n is 0. You can say that your C into n equal to 0. Either your C can be 0 or your n can be 0, or both C or n can be 0. That we'll see afterwards. Okay. Okay, so now I have here b into 1 minus 2a. Now my b is equal to 0, right? That means this whole term becomes 0 because my b is equal to 0, right? So that means I am just having two terms. So one term is having here eta square, and this term is also having here eta square. But now you can argue that this term can have also eta square if my c is equal to 1. But if your this term in this term, if c is equal to 1, see, then you have here eta square, here also eta square, and no eta term. But in this expression I have one eta term also other than eta square. So this term cannot be eta because it is already eta square. But if this term here I have c equal to half, then this term can be a term containing eta. So that means from here, comparing this term and this term, okay, I must have my c is equal to half, and what else? Okay, what else? My c square d square is equal to h l square by k into capital H. And if my c is equal to half, then my d square is equal to 4h l square by kh. That means my d is equal to plus minus root over of 4h l square by k into h. Clear? Okay. And now I have already my b is equal to 0, right? So that is something counterintuitive. So what that can be? So I think there is some mistake, because here I have one eta square. So from where I got my b is equal to 0? Because I am not having any term here as eta square, right? So have I done any mistake? I think it is all clear, but still I am having an extra term here. It is one term containing eta and another containing eta square. So you see the problem here, that is this term is containing eta square here, a finite term, but here my b is already equal to 0, right? So can I have any other option other than b is equal to 0? No, I cannot have. My b must be equal to 0. Just let me see, I have done this problem previously also, or otherwise you guys can see that if there is any mistake or not. Okay, so I think I have found the mistake. There should not be any term containing eta square. I have committed an algebraic mistake. Okay, just let me see that where I have committed the algebraic mistake. Okay, so here in this problem, what was my L? L is this. Okay, so I was correct that, see, then so if this is the fact, then you cannot convert this equation into a Bessel equation, then you have to find another method. Okay, so if you put another assumption, okay, so that is why I was putting that assumption there. That is, what is my perimeter? Let me go down to very back. Okay, so here I will consider it as my 2 into W. In what condition? So I am taking here an assumption, okay, that is my W is much greater than 2h. So if my W is much greater than 2h, then W will be greater than any height. If W, this part is much greater than this part, then this W is much greater than any height along this, right? Okay, so have you understood that up till now what I have done, there is no mistake here, but according to this equation and the Bessel equation, I cannot say that this is a Bessel equation, okay, because I cannot match this term to this term correctly. So I am taking another assumption, okay. In the real world this assumption may not be correct, but I am taking it for the I mean I am taking it having the purpose in my mind that I have to explain you the Bessel function thing, okay. So then my perimeter is becoming 2 into W, right? So then if it is becoming 2 into W, then this part will not be there, right? This whole part will not be there. See, now this part will not be there, right? That means this part will not be there, this part will not be there, okay, and this part is eta, okay. That means in my final equation my this part will not be there. Now if this eta is not there, so for the time being I am considering that this is so this I am not considering. On which condition? Only if my W is much greater than 2h, okay. I have shown you that how it can come, right? So just for the sake of your understanding, I will be showing this again, okay. So if my, so where was those functions, okay, if my W here much greater than 2h, W is much greater than 2h, that means easily my W is much greater than any 2y. So this becomes only 2W, okay. That means I have called that this becomes 2W, okay. I am writing in this is approximately 2W if my W is much greater than 2h, right. Again that means this becomes 2 into W. I am writing everywhere for your understanding, okay. Again, where was those equations, okay. So that means this becomes approximately 2 into W if my W is much greater than 2h, okay. That means this becomes only W, right, if my W is much greater than 2h. That means again this becomes only W if my W much greater than 2h, right. Again everywhere here also this will be almost W because my W much greater than 2h. I am writing everywhere so that you don't get confused, right. So again this term will be approximately equal to W if only my W is much greater than 2h. Clear? Again this term will have the same thing, and finally here I will not have the eta, this whole term will be only W by h. Now if I am not having eta here, then see this term will vanish, okay. This term will not be there, this term will not be there, and that means my, and here also I am having this as 0, clear. That means I have got all the values, that is my A is equal to 0, A is equal to 0, B is equal to 0, C is half. Okay, now what about N, right? So I have my C into N equal to 0 and my C is half, that my N, that means my N is equal to 0. So A is equal to 0, B is equal to 0, C is equal to half, N is equal to 0. So I think 1 hour have passed, so I have to complete it soon. So N is equal to 0 and D is this and C is half. Okay, so now just let me check the conditions. So if I check the conditions, see, first condition is for N, so N is equal to 0. Okay, so N is equal to 0, and according to the conditions, if here N is equal to 0, okay, N is equal to 0 and D is what, here D is real, okay, D is real, I think this N is equal to 0 and D is real, okay, because this thing is real, there is no imaginary thing, right? Okay, now see the first condition that I have already talked in the video, I have already talked about that. Okay, so applying the first condition, I can get my y is equal to x to the power a is 0, e to the power b into x, b is 0, c1 jn, n is what, n is 0, so this is 0th order Bessel function. Now d is what, we will now you can consider both plus and minus, so afterwards you have to see that which thing you will be considering. Okay, so I am just writing here d and x to the power c, so c is half, so this will be root x plus c2 y of 0, again d x to the power half, that is root x. So this is the solution. Now you have to here find c1 and c2, and for that, so this is not y here, I should have written theta here, and also this is not x here, the solution I will get in terms of eta here, right, because I have already converted the governing equation in terms of theta and eta. So these are theta, sorry, I am extremely sorry. Okay, right. So now I need two boundary conditions. So one boundary condition is your t at x equal to 0 is equal to, t at x equal to 0 is equal to tb. So theta at x equal to 0 is equal to tb minus ta, and my eta is what, 1 minus x by L. So eta at x equal to 0 is equal to 1. So that means my theta at eta equals to 1 is tb minus ta, and my theta, eta tends to infinity, or eta tends to actually minus infinity. Okay, my theta, because as x tends to infinity, my eta is tending to minus infinity. Now I am having my t at x tends to infinity is at as my ta, right. So that means this boundary condition will give my theta as eta tends to infinity is equal to 0. Okay, eta tends to minus infinity. So now you put these boundary conditions and you will have a chart or a graph for Bessel function. Okay, so about that chart or that graph, and one more form of Bessel function, about these three things, the chart, the graphs, and the derivatives of Bessel function, and one more form of Bessel function. About these four things I will talk in the next lecture, but I have almost completed the fin thing. Okay, so I have almost completed the fin. Now see, again I am talking that the main thing is to formulate the problem. Okay, that is another issue, that in the examination you have to have the knowledge of Bessel function. Okay, that is at least how to compare the two things. But still, if you do only up to the derivation of the governing equation and you write the boundary condition, still you will get at least 60 to 70% marks from that teacher. Okay, because that is the main crux of conduction. I think you have understood that how to formulate a fin problem from very basics, and you need to keep that into mind. Now just practice the Bessel function once. Okay, now I will talk about all the four things in the next lecture, and until that, if you have any doubt, just put that in the comment box. I am always here to help you, and if you feel that anything is illogical or any step you are not understanding, still you can put that in the comment box. So until the next lecture, goodbye, take care and thank you.